Hello children, welcome back after summer vacation with a new chapter, that is chapter 2, are acids, bases and salts. Okay, so earlier we have completed chapter 1. I'll provide some of the board questions also. Now in this chapter, what all subtopics we are supposed to cover? Let's see what are all the subtopics. First we will identify through some of the characteristics of acids and bases. How to identify this acids and bases? Next is what are the properties of acid and base? How will we identify the acids and bases? And what are the common properties? Generally what we tell that acids are just having the reverse properties or opposite property to that of bases. Okay, that's why when we have the reaction between an acid and a base, both are countering or cancelling their property, and this is called the neutralization reaction. So it sounds something different, that acids and bases do have some common property. We will see what are the common property of both acid and bases. And then the neutralization, that is formation of salt. And in the topic salt, we will see what are the various types of salt and the examples, the preparation, properties and the commercial uses of some of the salts. Some of the commercial substances preparation also we will see, that is sodium chloride, caustic soda, sodium hydroxide, sodium carbonate, decahydrate, what we call washing soda, sodium hydrogen carbonate, or we call it sodium bicarbonate. Bi stands for hydrogen, but now according to IUPAC convention, this is sodium hydrogen carbonate, also known as baking soda. You might have known that in cake and bake industries we use baking soda as well as baking powder. These two are different. Here this is the baking soda. These all are the sodium compounds, and we will see the calcium compound as our bleaching powder. Though this is just the chief component of bleaching powder. Bleaching powder is basically a mixture of some other compounds also. This is the chief constituent of bleaching powder. And one more compound, that is plaster of Paris. That is used in the setting of fractured bones as well as the casting, molding of statues and all. So all these we will study in this particular chapter. Shall I erase this? Now let's see what actually is the parameter. How will we identify that yes, this particular given substance is an acid and a base. Let's introduce a term called indicator. Now the term itself is telling to indicate. What is the meaning of this, dear? To indicate means to point out. I am indicating something means I am pointing out to something. Now what to point out? I am giving you just one example. In one test tube, suppose labeled as A, another test tube labeled as B, another test tube labeled as C, we all put some colorless, odorless liquids. All the three liquids are colorless, odorless means no smell liquids. We will not be able to identify that which one among these three is containing acid or bases or even water is present. All will look alike, whether it is acid, whether it is base or it is a pure water, distilled water, all will look similar because all three are colorless and odorless. Now here only we use this particular thing, that is indicator, which will point out. Most probably from class 7 onwards you are studying what are acids, bases and salts, and there it has become a practiced one only. Whenever we are talking regarding acids, you all will tell that yes, acid is a substance which turns blue litmus red, and base is a substance that turns red litmus blue. So here litmus is the substance that helps out to point or to detect, to indicate that which one is acid, which one is base and which one is a neutral one, that is the distilled water. So let's see this all. Though in next other classes I'll describe what is actually meant by indicator and what are the various types of indicator, their behaviors also. So I'm just telling you that this is the substance which undergoes the changes in their physical properties. Say suppose the change in color or might be change in smell or other properties when these are treated with acid or base or the neutral one. That's why these are called the indicators. One of the natural indicator is litmus, which is obtained from lichens. We have some other synthetic indicators or man-made indicators too, and the indicators are methyl orange, phenolphthalein. Later on some other indicators also you will come to know, that Congo red, methylene blue, all this. And beside this litmus as a natural indicator, we have some other natural indicators too, that is the China rose extract, turmeric powder. All these are natural indicators. Now let's point to acid first. Hope so we understood what is the indicator, though we will have a complete class on this indicator, and also one short exercise. So this acids, they are having certain features. One is they are normally sour in taste. For example, citrus fruits, the lemon, oranges and all other such category foods are containing ample quantity of vitamin C, or that is called ascorbic acid. The chemical name of vitamin C is ascorbic acid. So by the presence of this ascorbic acid, all the citrus fruits are sour in taste. They also contain citric acid, tartaric acid and many other organic acids, that is acids having the living origin. One more important thing regarding that is they are corrosive in nature. Corrosive in nature means they are harmful to our cells and our tissues, that is muscles and all this, harmful to living cells. Even if we will touch the muriatic acid, what is actually the toilet cleaner, the main constituent of Harpic, we will find the itching over our skin. So that is due to the corrosive nature of acid. And the way to identify acid is it turns blue litmus, red, acids. There are some more chemical properties also that we will deals with later on. They turn blue litmus red. The next one is all these acids, they turn methyl orange, a synthetic indicator which is itself orange in color to pink. And phenolphthalein, see the spelling, though we call it out as phenolphthalein, but it is actually phenolphthalein, another indicator. And while pronouncing this, we are not pronouncing L, P, L, P and H. We are not calling it as phenolphthalein. This is phenolphthalein. That is phenol and phthalene we are calling. This L is not there, H is also not there while pronouncing this. We call it as phenolphthalein, but the spelling is actually phenolphthalein. This phenolphthalein is itself colorless and that still remain colorless in acidic medium also. That means we do not have, if the phenolphthalein solution is given only an acid or a neutral species is given, we will not be able to identify the acid as well as the neutral species by using phenolphthalein only, because both in neutral medium as well as in acidic medium it remains as a colorless one. No change in color is observed. Now let's come to the main constituent of acid. Whatever is there in your syllabus, this is restricted to that. This acid will all contain hydrogen. For example, we have the common acids. What we use is hydrochloric acid, sulfuric acid, nitric acid, and so on. We will see that all the acids are having hydrogen as one of the constituent element. So, in the next point that we say that acids are the substances that furnish or release H plus hydrogen ion. In fact, I could write it in H3O plus hydronium ion in aqueous solution, means its solution in water, as the single positive ion or as the only cation. Let's see what is the meaning of this. I told acids are the substances that are able to release hydrogen ion or hydronium ion in aqueous solution as the single positive ion. Let's see what is the meaning of this. Now, if I take the example of HCl, in aqueous solution, HCl will break up, will dissociate to H plus and Cl minus. So, which positive ion we are getting? H plus as the only positive ion. If we consider nitric acid, HNO3, that is also in aqueous solution, will give us H plus and NO3 minus. So, all such acids are able to give H plus in aqueous solution. Actually, in water, this H plus is not remaining alone. This is the small H plus surrounded by the water molecule, and therefore this H plus is actually taken by water, called H3O plus C, H2O and one more H. So it is H3O and this positive charge. This is called hydronium ion. Practically, in aqueous solution, there is no free hydrogen ion. It exists wherever water is there, it exists as hydronium ion. Now, which point I was telling that it is evident acids are releasing hydrogen ion and later on that is being converted to hydronium ion in aqueous medium. I said that it is the single positive ion. Let's see, look to this point. Say suppose we have a compound NaHCO3, sodium hydrogen carbonate. This in aqueous solution will dissociate to sodium ion, hydrogen ion, and as you know, carbonate is having a valency 2 minus. So overall the net charge is 0, plus 1 and minus 2. Net charge is 0. Now in this you will tell, yes, now this is also generating a free hydrogen ion, but along with this free hydrogen ion, one more positive ion is there, that is sodium ion. So I said in the definition of acid that these are the substances which can furnish, which can release hydronium ion as the only positive ion. Since this compound releases two positive ions and one more positive ion other than hydrogen ion, this is not an example of acid. If we take the example sulfuric acid, first hand it dissociates to H plus and HSO4 minus. It could also dissociate as 2H plus and 1 sulfate ion. So in this case, we could find that hydrogen ion and hence turning to hydronium ion is the only positive ion. But in other compounds, we could have hydrogen ion in aqueous solution, but along with this, some other positive ions are also there and therefore these are not acid. So, what is the complete definition of an acid? The substances that are able to furnish, able to release hydronium ion as the only positive ion in aqueous solution is called an acid. I repeat, acids are the substances that are able to produce hydronium ion as the single positive ion or only positive ion in aqueous solution. This definition was given by a scientist called Arrhenius, and hence this theory is also known as Arrhenius theory. Later on in higher classes you will study this, and this concept actually includes the acidic behavior of only those substances which are soluble in water, because every time I am telling that in aqueous solution they are releasing hydronium ion as the only positive ion, and you will be surprised enough if we pass dry hydrogen chloride through blue litmus paper, it will still remain as blue. The blue will have no change. Why? Because it is dry, and in absence of water it is not able to furnish, not able to release hydrogen ion. That's why this concept, and actually this is there in our syllabus only. Our syllabus is restricted only to those concepts in which we are considering acids are hydrogen containing substances, and number 2, acids are water soluble. So finally we got the points. Let's summarize. Acids are having the property of sharp test, corrosive nature, turns blue litmus red in presence of moisture or water, turns orange color of methyl orange indicated to pink, no change in phenolphthalein indicator, and finally acids are hydrogen containing substances. They are able to release hydrogen ion as the only positive ion. Please students, go through this entire work so that in the next class we will be able to continue with the next portions of acid. Okay, treat this video explanations or the PDF notes or whatever you are getting as equally important as your live classes going on. In case you do find any difficulty after watching this video, please inform me immediately. I will clarify your all doubts. Thank you, dear.